Welcome class, everybody. We're going to look at a situation where if you were to jump off a diving board and fall into the water, the question would be, how much acceleration do you feel when you are hitting the water? Because if you think about it, when you jump off of the diving board, your speed's 0. And at the very end, when you're in the water, as you stop, your speed's 0. So for some reason, the beginning 0 and the end 0, but it doesn't really make much sense. So what we're going to do is we're going to look at this in terms of two steps, as the falling portion and then the going in the portion. So we have ourselves a high dive. I'll give you the link. Go check it out. But he jumps from way up in the air. Here he is right here. And he's going to land in this little pool. And as he lands in the pool, here's the question I want you to think of. When is the acceleration greater? In the air and the water? And why? What's the acceleration in the water, positive or negative? Okay, we've said acceleration due to gravity has been -10. So is it going to be positive or is it going to be negative? Make a prediction. How would you attack the question is, what's the acceleration in the water? What steps would you do? And then this is a good one. What would the graph look like? So pause the screencast, go and do it, and good, you should have paused, you're back. So jumps off of the diving board, and then when he hits the water, he has another motion. Okay, so you want to break it up into those two parts. So he drops off a diving board 52 meters high. He enters the water for 3 meters. What is the acceleration in the water? So that is our goal. So if I were to look down here, my goal is the acceleration. This is all I have. This is all the information I have. Crazy guy jumps off, and he goes. So let's break down my information. Up here, I have the initial velocity is 0. The final velocity, I don't know, the acceleration is -10. The displacement, should be writing delta x, but displacement is -52 meters because he dropped. Time, unknown. When he enters the water, though, he also has an initial velocity. And then he has a final velocity. His acceleration, that is our goal. The displacement that he has is -3 meters. He goes in -3 meters. So, as you look at this problem, what I want you to see is something from the top portion up here relates to the bottom portion. What is that? What variable? So hopefully you said the final velocity that you have right here as you enter the water is the same as the initial velocity that you have going into the water. That those two are going to be equal to each other. So let's solve for that. Notice, we don't care about time. We don't care about time down here. All we care about is that final, and we're going to plug that in and say that's our initial. So off we go. V final squared, V initial squared, plus 2AD, or delta x. So V final squared, plug in, you get V final to be -32.25 meters per second. Now again, on all these screencasts, pause and go back if you don't know where we got it. So that is now our initial velocity for our second part of our motion. And so now we can look at our second part of our motion. So V final squared equals V initial squared plus 2AD, or delta x. And so our final velocity is 0. Our initial is -32.25 squared plus 2A delta x. You get an acceleration to be positive 173 meters per second squared. That answers a lot of questions. This is 17 times gravity. 17 times bigger. So whatever you feel from the earth pulling on you, this is 17 times bigger. Is not going to do well. Why is it positive? So as I fall, during my falling portion, let's do this in a different color, so highlighter. As you fall, gravity is pulling you this way, so the acceleration is down. But as you hit the water, which way is it applying a force to you? Up. So the acceleration is upwards. So we'd say that this is a negative because it's downwards, and this is a positive because it's upwards. Now, graphs. Very important that you can draw these graphs. I think it's going to bring things together. This will be our last thing, and then we are all done. So my initial velocity is 0. My final at the very end is 0. My acceleration at the beginning is -10. The acceleration at the end is 173. I speed up negatively, and then I abruptly stop. Position graph. I should see I start very high, and I fall, and then once I hit the water, this is the water level, that I abruptly come to a stop. Once again, this should not be your senior project, and hope that helps. Tomorrow we're going to do a little bit more with these two-step style of questions. Have a good one.